Alright, hi everyone, hope you're all well and you've had some imaging opportunities with clear skies. So the last couple of nights here in Cyprus I've been continuing to try and hone in the equipment in the observatory and on the Edge 11, which is still currently set up in there. The M101 imaging session I did a couple of videos ago. I know the quality of that image still wasn't spot on. Particularly the focus was out slightly and the post-processing didn't go smoothly with the quality of the lights, the flats and obviously the lights. So I've been back out again, and the last video I produced was the SQM meter installation on the observatory, and last night I set that up to do a full capture of the sky quality throughout the night from sunset to sunrise, just to see how that data would come out. So we'll take a look at that as well today. So first up, in Ruzeen's June update, that's Ruzeen from Astrofarsography. I'll put a link to his channel below in his video. He mentioned one of the targets for June was to take a look at C12, the Fireworks Galaxy. It's also known as 6946. So this is on the boundary between Cepheus and Cygnus, and it was dubbed the Fireworks Galaxy after having had 10 supernovae observed over the last century in this galaxy. So fortunately for me, it sits in my north-northeast sky, and it rises just after 9 o'clock, and I can capture it as you can see here. It runs all through the night until sunrise in the morning, where it's probably hitting its peak altitude there. So I set up a APT and I captured 206 light frames, and I also took 20 dark frames and 35 flat frames, and the light frames were recorded at 120 second exposure, and the camera was set at -10°C. So after downloading all the data from the observatory, I took it all across into Blink in PixInsight. And I did a number of passes on the data just to continue to pull down or try and acquire the best of those images. And as you'll see when I run the Blink, there was still a lot of problems, particularly with tracking in the observatory, and you'll see there's a period as well where the dome slit actually overlaps the telescope and we get an increase in brightness in the image. So all these images were filtered out. So if I just run the Blink, you can see starting there, we just run it down through, you can see the images are all over the place, and then we have a period of stability, and then we have a couple of flashes as the telescope's overlapping, and then we've got sunrise kicking in there. So as I say, I did a couple of passes on those data, and on the second pass, I just keep moving the images into the new images, into the new folder. So if we load up the final pass, okay, so as we run that Blink, we can see we've got much better quality of images, although at some point it does start to track off again. And I don't know if that was the auto-guiding starting to lose the star, and as one of the bright periods came through with the observatory rotating. So anyway, after taking all those images and running through DSS, I tried that a couple of times just to see what I can get. And as you can still see, despite various tweaks and things, I still haven't got a good starting point. I think I need to modify my flat files, maybe increase the duration of the exposure on the flats just to brighten it up. but these are things we'll just have to keep trying. And anyway, I ran through PixInsight, various usual things, curves and DVE extraction, and a couple of other tweaks as well. And this is where we got to. So it's certainly better than what we started with. There's a bit of a crop there obviously as well, just to take away some of the far edge extremes. And considering the data I got wasn't the best, it's still a reasonably good outcome, I would say, although it's not as good as I want it. But again, that's why we just keep trying all different things, different techniques, and until we can hone in our skills on the image gathering. So that was the Fireworks Galaxy. Alright, so over to the Sky Quality Meter. So the first thing I did, I go into the observatory. I used the SQM reader tool just to take a sample every 1 minute and record it to a text file. And then I extracted this text file across to my main machine, and you can see here it gives you the date, the time, the magnitude per second, spark second squared. It also gives you the naked eye limiting magnitude, which is this -13 running up to all the way up to 5.6, I think it was. And then we've got a couple of parameters around the model version and feature set. And then the last data column there is the ambient temperature recorded from the SQM meter. So I took all that data and I imported it into Excel, let it parse out the columns, and then using the Bortle scale from Wikipedia, it gives you the approximate SQM equivalency. This, for example, here, click Bortle 5, 19.5 through to 20.49, and I added those columns onto Excel and just ran them down there as a reference point on the chart, and then imported all that and created a chart with the data here. So here we can see throughout the evening the temperature just continues to drop all the way down till the lowest point was around about 5:15 in the morning, before it rapidly starts to rise again as the sun rises. And the Sky Quality Meter readings really kick in. What time is that? 7:30 in the evening, and then continue right through till probably back at 9 o'clock, where it starts to flatten out, and we get the best Sky Quality reading at 1:55 in the morning. So when I go outside and have a look at the sky, I think, yeah, okay, we're good to go. The reality was we were still down in this Bortle 8, Bortle 9 area, which doesn't look like it outside, and that's where I would typically go and start setting up, but probably start imaging when I think it was dark, which was around about 9 o'clock, but again we're still in a Bortle 6. So using the Sky Quality Meter, I can see when it starts to level off and really when is maybe the optimum time to start an imaging plan. So if we just nip back quickly to the observatory, wherever that window's gone, in APT, so it's currently not reading from SQM at the moment because I've reconfigured it to read through APT. And if we go into APT, we can see now that it's set up to be recording from the SQM. On the graphs SQM reading, you would see the trend appearing on here. Unfortunately, the graphs has got a fixed number of data points, and it doesn't do a full evening session, so I can't see a full graph on here. That's why I elected to do it on the data gathering through SQM. And on the left hand side we can see it also adds in the Sky Quality Meter reading at any given point in time when it does the samples. And if we double click on here, we can also see it pops up this little dialogue which gives us the current Sky Quality reading in naked eye equivalent, and also the current ambient temperature being read by the sensor. So that's the Sky Quality. readings in APT and on XL. So it certainly gives us more things to consider when we're developing our image plans. And as I said in the first install video, if we pop across to one of the files that I captured, wherever that window's gone, so that happens when you've got too many screens, incoming, fireworks, lights, past 1, past 2, and if we go into one of these files here and open up the FITS header, you can see down at the bottom here it's added the SQM reading into the image. Astrophotography tool injects the SQM reading into that FITS header for reference. So that's maybe something else again that you can use as a reference point whether you want to consider your images as you're going through the filtering. Alright, so really that's all I've got a quick update today, and we'll see where the next thing's going to do. So in the meantime, thanks for watching, and on that note I wish you clear skies and hope you get out and about soon. So thank you very much. I'll speak to you later.